we are in AB calculus AB self-check 4.3. Let's say number one, let f be a function defined by that thing. Looking for equation for the line tangent. As soon as you see equation for the line tangent, this thing, equation for the line tangent, you immediately go y minus box is equal to box times x minus box. And then from there, we're just trying to fill in everything. It already gives us our x coordinate of -1, so we're going to plug in -1. We need to find this y coordinate, which means we're going to plug in -1 into this equation up here, and that's going to be f of -1, and that's going to be 4 times -1 to the power of 3 minus 5 times -1 plus 3, which is going to be equal to -4 plus 5 plus 3, which is going to be 4. So the y coordinate here is 4. And then from there, we need to find the derivative, the prime that goes in here. So to find the derivative, we need to find f prime of x. That's going to be 12x squared minus 5, and then we're going to do f prime of the x coordinate of -1. Plugging -1 into the equation above gives us 12 times -1 quantity squared minus 5, which is equal to 12 minus 5, which is equal to 7, which means our slope here is 7. I noticed that this is the right answer, but I don't see that anywhere over here, and that's because they didn't use point slope form, they used slope intercept form. So slope intercept form means that I need to distribute my 7, add the 4 over to the other side. Let's see what I get. So this double negative here is really a +1. So this is going to be y is equal to 7x. When I distribute 7 into 1, I get +7, and then I need to add this 4 to the other side. So I get +4. 7 plus 4 is 11, and I get my final answer of C. I see a lot of people writing things down, which is why I'm pausing the information. Go get some water from my delicious Walla bottle. I just cleaned it out 2 days ago, so it's tasting really fresh and cold.
How did you clean it up?
So when you have a baby, you need a bottle brush to get inside of things because it's so hard to clean bottles. So I have this mega awesome bottle brush that is scrub it out with super hot water. You can take apart the whole cap. I haven't run it through the dishwasher yet, but I can probably do that.
Does it taste better?
I think it always tastes better after you wash the water bottle. That's just me. All right. Questions about number 1. Moving on to number 2. Function f is twice differentiable, and it gives us an x coordinate of 2 and a y coordinate of 1. It also tells us that when we take the derivative at 2, we get this 4, and that's going to be our slope over here. It says, the second derivative, I don't even know if I'm going to need slope, and it says the second derivative, the concavity is positive. It's a +3. What is the value of the approximation of f of 1.9 using the line tangent to the graph? Okay, every single time you see line tangent to the graph, you immediately go y minus box is equal to box times x minus box, and you fill in what we got. We have an x coordinate, we have a y coordinate. So our x coordinate is 2, our y coordinate is 1, and it tells us what the slope is. I thought we wouldn't need slope, but we do indeed need the slope of 4. That's the slope at 2. So this 4 is going to come down here, and I'm going to say 4. Take the color here, 4, and I'm ready to go. This is kind of interesting because, okay, I think I know this is not used ever. This would be useful if there was some sort of, is this an over approximation or under approximation, which is usually the follow-up question, but that question isn't here. So this is the one time so far in this course where we've been given information that we are not going to use. All right, so from here, I'm going to take this 1.9, plug it in for this x, and let's see what we get. I get y minus 1 is equal to 4 times 1.9 minus 2. Okay, a bunch of mental math here. 1.9 minus 2 is -0.1 times 4 is -0.4. So I have a -0.4 on the left, y minus 1 on the left. Or sorry, -0.4 on the right, and then y minus 1 on the left. Adding 1 on both sides gives us y is equal to positive 0.6. Correct answer here is B, 0.6. Again, I see a lot of people writing. I don't even need to ask, but I can tell that probably weren't sure what to do with that question. All right, questions on number 2 before we move on to number 3? All right, and this hasn't been labeled though, except in the future. And number 3, we have that equation, and we're trying to find y prime, and it tells us a point, and we don't have y prime, so we need to find y prime. I'm going to immediately take the derivative, so I'm going to get a 2y prime minus, okay, product rule, and I have to be careful with my negatives here. I always mess up with my negatives. Here's what I'm going to do. I'm going to consider negative 2xy. I'm going to consider all of this negative 2x to be 1 and all of this y to be 2 so I don't make mistakes with my negative. That's how I'm choosing to isolate my 1d2 plus 2d1. So when I say product, it is product rule because I have two variables being multiplied. So I'm going to say this is going to be 1d2 plus 2d1. We'll see what we get here. So 1 is negative 2x. I've already written that here. And I'm going to multiply that by the derivative of 2. The derivative of 2 is y prime. Plus, I'm going to say 2 is y. And then the derivative of 1 isn't just x prime or nothing. It's negative 2. I think this negative 2 here is probably the trickiest part of this entire problem. And then I take the derivative of the right side of the equation. The derivative of 21 is just a constant, so it's 0. And I'm going to immediately plug in my x coordinate of 2 and a y coordinate of negative 3. So I'm going to say this is going to be 2 times negative 3 times y prime minus 2 times, here comes my x of 2 times y prime plus y, which is negative 3 times negative 2, and that's all still equal to 0. And this has become a much easier problem. I'm going to go ahead and simplify here. I have a negative 6 y prime minus a 4 y prime plus a 6, and that's set equal to 0. I have a total of negative 10 of these y primes, and that's going to move that 6 to the other side, so I'll get a negative 6 on the right-hand side. If I divide both sides by 10, I get y prime is equal to a positive 6 over 10, so negative divided by negative is positive, which reduces to a 3 over 5, a positive 3 over 5, might I add, which means our correct answer here is E. All right, that one had some work on you guys. Tell me about number 3. How'd you guys do?
I guess.
Guessing you got it wrong. Got it wrong. Where'd you go wrong?
I went wrong with the negative.
With that negative over here that I was thinking about. Yeah. So there's two methods. My method is include the negative in one, but the other way to do it is take the negative and then put parentheses around the whole thing and then distribute the negative at the very end. Those are kind of two schools of thought on how to do those. And Giorgio, how'd you do on that one?
I got the 2y prime, and that's as far as I got.
No.
So it's like,
Okay. Let's move on to number 4 on the back. All right, we have that equation and we're looking for y prime and we can't plug in anything. I'm noticing all these answers are disgusting fractions. All right, here we go. I'm looking for y prime. I don't have a y prime, therefore I need to take the derivative. Here we go. Derivative of x squared is 2x. I don't know why I wrote x first. Plus, okay, I have xy, which means this is going to be my 1, my 2, and then I'm going to do product rule. 1d2 plus 2d1, and done, okay. Plus the derivative of y cubed is 3y squared, and then take the derivative of the inner y prime. That's all set equal to 0. So there's the correct derivative on the left. And now I just need to isolate a y prime. So anything that is not a y prime, you and you need to move to the other side. These have a y prime, so they get to stay behind. So if I do that, I'm left with an xy prime plus 3y squared y prime. And on the other side, I have a negative y and a negative 2x. So far, so good. From here, I'm going to turn 2 y primes into 1 y prime by factoring out that y prime. Meaning I have a y prime out here, and I'm left over with an x plus 3y squared after factoring out that y prime. The right side has not changed. All right, and right now I have y prime times some stuff. So the opposite of times some stuff is to divide by some stuff. And we're going to divide both sides by that x plus 3y squared. Divide this side by that x plus 3y squared. And we get y prime is equal to that thing. And I think I'm looking at a lot of these answers, they put the x first. So I'm going to go ahead and put the x first as well. I'm going to say this is negative 2x minus y all over x plus 3y squared. That doesn't look like some of those. It looks very similar to this one. Kind of similar to that one, but there's no 1 down there. So I think the answer is this one. What happens if I take this negative and factor it out? If I factor out that negative, then the negative is going to come out in front, and I'll have a 2x plus y in the top, and an x plus 3y squared in the bottom. And that's exactly what they did for A. It's the correct answer is A. If you have excellent guessing skills, you can get quite a higher score on any EPP test. All right, questions about number, I think it's number 4. No questions. We're moving on to number 5, the last question. An equation of the line tangent to this thing at its point of inflection. Okay, well, it's an equation of the line tangent. Every single time you see equation of the line tangent, you immediately go, y minus box is equal to box times x minus box. It's those key words that tell you what to do. Those speed sheet definitions. All right, so I don't have anything. I don't have an x. I don't have a y. I definitely don't have a y prime. There's a lot to find here. So first of all, we're using this speed sheet definition of point of inflection. That's where what? F prime or F double prime? F double prime sign change. So that's the definition of an FIP, an inflection point. So we need to find the second derivative. Again, speed sheet guides us on what we're supposed to do. We're supposed to find F double prime. We only have F. So let's go ahead and find it. So I have y prime here, taking the derivative of all these terms. X cubed turns into 3x squared plus, 3x squared turns into a 6x, and then the 2 turns into a 0. So don't worry about that. Done. Take the derivative again because we're looking for the second derivative. The 2 comes down front, and I get 6x plus 6, and then that's the same thing as 6 times the quantity of x plus 1, just factoring out a 6. And if I set that equal to 0, I get 6 times x plus 1 is equal to 0, divided by the 6 and it's gone, and x is equal to -1. That is probably the point of inflection. If I go ahead and look at the sign up here, this doesn't have a sign for, not sign, but the power here. The power here is 1, which is odd. The parity of that power is odd. If it's odd, it is a sign change, so I can verify -1 is a sign change, and it's a sign change on the second derivative, therefore it is an inflection point. So we have an x-coordinate with a lot of work, we can finally put that in. Normally those are provided to us. So I have a -1 here for my inflection point. Okay, now that I have an x-coordinate, I'm going to plug this x-coordinate into the normal equation to find the y-coordinate. So here it goes. I'm going to say, if I plug in the y-coordinate, I'm going to say the y-coordinate is going to be -1 quantity cubed plus 3 times -1 quantity squared plus 2. That's going to equal -1 plus 3 plus 2. That's going to be equaling 4. All right, so we have a y-coordinate of 4. And the last missing piece to our puzzle is, what is that slope? The slope comes from the first derivative, and we have the first derivative over here. So I'm going to take this first derivative, I'm going to come down here, and I'm going to plug in -1 to each of these x's. So here I go. I'm going to say y prime, I'm going to change to a different color here. Let's change to our third color black. Y prime here is equal to 3, not x, but -1 squared plus 6, not x, but -1. All right. What is this thing going to be equal to? This is going to be equal to 3 minus 6, which is equal to a -3. All right, so we have the slope of -3, we have the x-coordinate, we have the y-coordinate. We just need to write it in the form that they're asking for. I'm noticing that each of these 5 forms is slope-intercept form, which means we need to distribute, and we need to add this 4 to the other side, and we will be done. So it's going to turn into, final color is going to be purple, sure. Y minus 4 is equal to, distributing the -3 gives us -3x, and then -1 is that positive on the inside here, but distributing the negative will make it negative again, and I get a -3. If I add the 4 over, I get y is equal to -3x plus 1. -3x plus 1 is B. Correct answer, B for number 5. That was a truly hard question. If I saw this type of question on the AP test, honestly, if I were in your shoes, I would probably be like, I'm gonna come back to you if I have some extra time. 'Cause I know how much work is required. I don't even have an X coordinate. I have to find a point of inflection which requires work, and then I'll have to find the Y coordinate, and then I'll have to find the slope. Like there's so much work that goes into this problem. If I'm supposed to average 2 minutes per question, you bet your butt I'm gonna come back to this problem if I have extra time, because that required way too much time. And that's the strategy. Time management skills on the AP test. All right, so out of 5 fingers, how many points did you get?
Are we including guessing?
Including guessing, we'll include it. Woohoo! 1, 0, 1. Yeah. That was a much harder self-check. Don't celebrate the fact that you got a low score. Celebrate the fact that you will get smarter after this. I'm guessing you guys learned quite a bit on this one now.
Yeah.
Yeah.
I don't
This
look
was a
back.
harder unit than the rest. I'm gonna be honest. I found that it was way harder of a unit to understand.
And I feel like